Alright, so let's talk about class in Java. So first, what is the first class that you have learned? Hello world, okay. How do you create a hello world? You just, if you use the IDEs, you generally just go to new project, create a project first, right? Let's say this is going to be 5.2, and you're going to create a new class, right? So this is how we create class. We pretty much keep creating class every time. Right click new Java class, correct? And you say hello world, right? So that's the first class that you create, right? So you also learn, yeah, pretty much use the method public static void main. So this is no longer new for you. It's easy, right? So now, what is the first class that you use? Okay. System. That's a class, right? So how do you know this is a class? Okay, like we said, naming convention. Naming convention, one way to look at is you capitalize the first letter. That's a class, right? And location of this class is where? Java.lang. Do you understand what that means? So java.lang technically a package. A package is pretty much just a folder named Java and subfolder named lang. And that file system.class pretty much just in there, right?
Can we write java.lang.system?
Yes, we don't have to import too. But we don't need to import anyway, because all the program, all the classes that resides under java.lang, you don't need to import because JRE automatically import it for you, right?
Is a class, right? System.
That's what we just said. System is a class.
Sorry.
Now,
for there to be like something sort of like IntelliJ, or how in Java all the .lang stuff is already imported. Why isn't everything just already imported into like when you're writing your code, and then the stuff you don't use just gets like moved out? Yeah, it's in when you're writing your code, right? So you like can, if you want to use math, you can without having to import it, and then once the code runs, it like filters through the stuff you don't need. So that you
so this is a question. Say, why don't we put all the classes under java.lang, right? How can you really do that?
They're not all under Java.lang, like they're all still separate, but it's just they're all like accessible without having to, you know, find every import statement that you need to do a certain function.
Or the question also said, oh, okay, since we cannot list all the classes under java.lang, the reason is, first, it's not organized, right? Second, when you create a new class, how are you going to put in java.lang? Like, I just create hello world class, right? This is a new class, right? How am I going to put in java.lang? Can I put in java.lang? Let's see. You know, when you put in the package, you just say package, right? Java.lang. It's maybe package name java.lang does not correspond to the file path. Detect package statement that do not correspond to the project directory structure and reports. So another question actually said, okay, since we cannot reach cannot put other classes in java.lang, then we technically can create our own package, right? Like we could create a package, like the naming convention pretty much just organization unit, like edu and vcc, and just like the website, right? But put the edu come first, csc, like that, right? csc and 200 class. Now it's pretty much the same problem here, huh? The reason actually because you need to create a subfolder, right? Like I said, this is a location and you have to move your hello world into that subfolder, like edu and vcc and csc 200. All right, like if I do that again, I could move it to that package. There you go. I have it under java.lang, right?
Now, is it in an internal package?
It's pretty much an internal, right? Because this is an external that you install JDK, which is under rt.jar java folder, a lang folder.
Project, right?
Yes, and this is system. So that's another path, right? And this is just another one in your own, right? Like you can name any package that you want, right? Okay, I will see if this is really important for you. We don't know. Is it going to be automatically import for you? Let's test that, right? So how do we test? We're creating a class. So just like we are using a class, we're using system. So let's look at javadoc for system. So this is a class system under java.lang. That's how you read. This is called javadoc, right?
Yeah.
So javadoc pretty much is a document for your class to tell you what's the purpose of this class. Contains several useful class fields and method. Cannot be instantiated. Right. So another way to use a class is like scanner. You have to say scanner keyboard equals to new scanner, that is instantiation, right? And system, you don't instantiate, you just do system dot, right? You don't instantiate, you just call system dot out dot print. Pretty much they are statics in front. If they have statics, then you don't need to instantiate. See, that's modifiers. Now, if you notice, class has what? Field and method, right? That's a summary here, right? So you pretty much look at the field summary and the method summary. The list of field error in out, the list of the methods, right? Copy, array, copy. So method pretty much an actions that you try to do, right? Like exit. Like if you want to exit application, we just call system.exit. Okay. So if I want to try to call a class, to use the class, right? So you use dot operator. So exit, you have to give the code according to that int status integer, right? It's pretty much just showing you how to use the method. Right, terminates the current running Java virtual machine. The arguments serve as a status code. Right, by convention, a non-zero status code indicates abnormal termination. Like that's why we normally put 0, like to specify the code that is normal. If it's exit with like different number, then it's abnormal. So technically, if I run this program, it's just run and then exit right away. So like this one, exit code 1, that means it's abnormally exit, right? Why? Prohibited package name java.lang. Because you are not allowed to name the package the same as the one in the library. Otherwise it's confusing. And then that's why it's exit with the error code. Right, error, a GNI error has occurred. Please check your instantiation and try again. So you're not allowed to name your package as java.lang. Then you can see we should not name package as java.lang. You can see we cannot create a class and put in java.lang, and java.lang pretty much just these are a list of classes that reside in this java.lang, right? Right. And if you read the package, like it's pretty much a common, right? Common classes that the system, when you run application, they need it. So, and the application don't have to really import when you use. So then java.lang is automatically imported for you. So let's see why java.lang is imported by default. Right, Java compiler automatically imports this package. So Java is a pure object-oriented programming language. So this class chapters 5.2 is very important. It's starting point of object-oriented programming that you want to focus, where code is written in form of classes. See that? So again, object-oriented programming is what? Language where code is written in form of classes. We have seen classes, right? I just try to emphasize the classes. So these class components are called types. Okay. All right, so let's read more details a little bit, okay? 3 packages are imported by default for each source file. First, the package with no name. Like when we do hello world, we don't have any name, right? Second, the java.lang package. And third, the current package, the package in which the current file is defined. So in every Java program, there can be one unnamed package, which is simply a package with no name. That's why you can run it, right? If you omit the package statement while writing the class definition, so we talk about the package statement here, right? Here. So the class name is placed into the default package. That's why when we run the program, so far we have that happens, which has no name. And Java compiler automatically imports this package. So the second package is imported implicitly, the java.lang. Java is a pure object-oriented programming language where code is written in form of classes. These class components are called types. Types in Java come in 2 flavors: built-in or primitive types. We already know that, right? Primitive types are like int, double, float, char, boolean, byte, what else? Short, long, 8 of them, right? And type form component. So now there's another type. You may see another type could be what? Like string, right? String is a type, but it's not a primitive types. So the primitive types can be used directly, while component types must usually be ordered from a library. by importing them from the appropriate package. The technical term of ordering a component from a library is bringing a component into scope. So the Java standard libraries, so we just look at, these are the Java standard library, right? So we install external libraries, JDK 1.8, JDK 1.9, right? Those are the standard library, right? So we mentioned that. Include the java.lang package by default, which contains a number of components that are used very commonly in Java program. You see that? Java.lang contains the components that very commonly used in Java programs. Java is useless without much of the functionality in Java.lang. That's why Java.lang is implicitly imported by compiler for all programs. So answering to that, right? We only want the common components that used in Java program to be in Java.lang. Okay? Because of the type, right? The primitive type and also the components type, right? And those components are called types, right? So the classes like system, right? Components, right? It's written in form of classes like string, right? If you look at string, should be in here too. Java.lang. Float, see that? Double. String. So those are common, right? System. Alright. However, one can import the same package or same class multiple times if you explicitly import in your program. Neither compiler nor JVM complains anything about it, but JVM internally loads the required class only once, no matter how many times you import the same class. Third, the current package is the one in which the class in execution is defined. Current Java package is ultimately imported by Java compiler. Alright, so now we have seen why we cannot list all other classes and ultimately imported them, because they're not commonly used. Now, when you're not commonly used, why you want to import them? And that Java classes, I'm telling you like that. Like now I create a new class again. Hello world. Everybody create a class. So it's pretty much uncountable, right? You have a lot of classes that coming up every day. How are you going to make it auto imported every classes? It's kind of impossible, right? So we just put the one that commonly used. Alright, so now we understand how to create a class, how to use a class. Now let me move this into the right package. So I move that into the right package, so it's pretty much just create a package, pretty much a subfolder for me to put that class. So if I run this program, it's pretty much just exit. Could I find or load main class? Okay, so when I make it exit the right way, then it's just complain because we don't have anything. We didn't write any code. So now this is just something that you have learned. Like besides system, what else that you have learned? Second class. Second class that you have learned is scanner. So how do you use scanner? How do you use scanner? You have to call the word what? Instantiate right? Instantiation. New is the keyword, right? And then yeah, you pass the parameters and you have to import, right? So that's another way to use a class, import and instantiate, right? And now you could start to put like get to the method of the class by what? Dot operators, right? That makes sense. But this type of class you don't have to instantiate, right? The system, you just call the method right away by dot operators, it's class name. But this type of class you have to instantiate, right? Now you notice that you being used classes, and there are two ways to use that. Make sense? Now you learn how to create a class. How to create a class again? Right click, new Java class. Hello utils. Okay, so I'm creating another class that has no main method. Pretty much just like your system, they don't have main method, right? Math class, scanner class, they don't have any main method. If you look at the method summary, right, in Java doc, you're not going to be able to see main under the summary. Pretty much list of all the methods here, right? There's no main in here. I, J, K, L. This is alphabetically ordered. So pretty much what type of this class? This is an object-oriented programming, meaning what? Meaning we create another class from other class. Like we create hello world class from system class, from scanner class. Make sense? So just like a water bottle, this is water bottle, right? This is an object, right? How do you create water bottle? You create from the caps. You create from, you have to have the label paper. Yeah, and you make a water bottle. But you actually look at water bottle, but it's come from different objects to make the water bottle. So this is object-oriented concept, right? So the main purpose is the water bottle to what? To hold the water. Now the main purpose of like hello world was just to say hello, right? But to do that, you are relying on what? System.out.print, right? To say hello, right? So same thing, the water bottle is relying on the caps, right? And the plastic that making it to hold the water, right? So it's relying on different other objects. So just like this, right? This is another class, a new class, hello world, relying on system class to say hello. And if you want to greet to the user, you are relying on scanner class, right? Because you need to read in the username, and you rely on string class to store the value of the user, while you rely on scanner class to get the next, to put the value in here. Right now, if I run the application, I should not say exit, right? So no longer exit. Now this hello world program pretty much just going to say hello to the name that I'm going to type in, right? That's the purpose of this. But to build that, you are relying on scanner class, string class, system class, three other objects. So object-oriented programming. Now, what is object? Yeah, what is object?
Like in this code, what's the object?
In general, what's object? Object. Anyone say I do not know what object means? Sometimes Google being spoiling us, huh? We just say object. So what's object? It's a noun, a material thing that can be seen and touched. Okay.
It's on the right side. Object, computer science.
Okay, in computer science, an object can be variable, data structure, function, or methods such as location in memory having a value and referenced by an identifier. Object can be many meanings, right? In English, writing a part of a sentence, right? That can be object, right? But in general, you can see what's object. Object pretty much something that you can see, you can touch, right? That's an object, right? A material that may be perceived by senses. Now, let's look at object-oriented programming. So, computer programming in which programming objects are used to form additional objects. Make sense? Like I said, the bottle, you need another object to make another object, right? And they also arranges into the hierarchies, which you learn in 201 hierarchies, and in which a single object member, such as, now we talk about members, right? Member of the object could be what? What's the member of the object? Look at Java doc. This is a member, right? Field and methods, right? Now, field, we also look it as just like a variable. We already know what's variable, right? And the method, we also looking as function. So we learn how to make a function or method from last couple class exercises. Remember that, right? Like now, you're looking at, these are just like a variables, or we call field, right? ERR, in and out. And these are just like a function we call method, right? Like array, copy, console. Like I just show you, I use exit, right? Something like that. So these are the function or the method. So object pretty much composes of the field and the method, or another word they call it variables, function. Okay, so that's object. All right, meaning that if I want to create a new class, what am I supposed to have? Field and method, or, right? It's a or, doesn't have to be both. A variable or function, you don't have to have both. Like when I create a new class, what do I have? Hello world. What do I have? A method named main. See that? So I create the object How do I create an object of hello world? Okay, let's say I make the hello util. That doesn't make sense to create an object of hello world, because hello world pretty much is going to say hello, right? But if I want to create another class that has no main, then I should be able to create object out of the hello utils, or another class that has no main, right? Pretty much a class that support another class when you want to build. Like I create a cap of the bottle. There's no reason to have the cap itself. Like the cap itself has no meaning, no values, right? The cap that will is you can't really use cap beside use it to close the bottle, right? So just like hello utils, I going to create a method. I can actually even create a class name bottle here and a cap here, right? So a name, a bottle cap, right? Because this represents an object, like we are simulating it. So what should a class has? We just look at it again if you don't remember variables or function, right? So again, what is the variable in this case? The characteristic of the object. Like if you look at characteristic of the system, I'm gonna have an error. This is represent the whole computer system here. And the characteristic of the system is gonna have what? Input. You read input, and then system going to display the output. Error, input, and output. Make sense? Those are the characteristics. So what should be the characteristic of the bottle cap? It's just the variables, like the color of the cap, right? So that should be a string type, because it's pretty much a variable, right? Variable. And okay, we can have more. Size, okay. Size should be, okay, let's say char, like LMD, large, medium, small. Or you can give the type, is it gonna be a number by centimeters, or right? Or like double size. You can always keep adding. So this pretty much create an object with the characteristic of the variables, right? So technically this is pretty much going to be a field summary, right? That we see here, right? So if you look at, here's the field summary. You see that? In, out, error. They create a class. That makes sense? This is just showing you the real system Java class that we being used. See? And they have the type. These are the type. Type like can be primitive type, can be another class as a type. Like in our case, type can be another class, which is string class. As a type can be primitive type. See that? Now we need the, like, it can be done by itself. Like it can be just the attributes, right? Because you can have the method, you can have the variables. Now the object has the characteristic. It also has the method or the function of the object. Like each object has the reason to maybe exist, right? Someone creating an object because there's a purpose to use it, right? Like system, class, attributes is error, input, output, right? Take input, display output, right? To the system. This is represent computer system, your PC pretty much. You can exit from the system as a function and action. So you can see an action pretty much as performing, right? Performing. So can you think of any function of the bottle cap? What's the function of the bottle cap?
Hold in water. Keep it inside of the bottle.
Okay, sealed, right? So just like the method that you always create public statics, okay, void sealed instead of main, right? So now you start to implement, just like in math, f of x plus 1 you implement inside, right? You increment. Now you want to seal. How you going to seal? So pretty much we have seal and we have to have unseal, right? Huh? The cap, right? So I'm going to create another method too. So you pretty much just need to list out all the method. Now the better place to do this is inside UML diagram. UML diagram is just like a blueprint that you do the layout before you start to build the house or the building. Same thing, we actually try to build it without designing it. So that's why it can be a little bit confusing if you try to do that at the same time, right? We should separate the concern. So I normally just use the lucid chart to create a UML diagram. Like, for example, this is an example of the UML diagram that I created to represent your bank account. So bank account is a class, so the first row pretty much is the class name, and the second row is much just all the field, right? All the variables or the characteristics of your bank account has account number, account name, the balance, and the interest rates, right? So that's pretty much just the field or the characteristic of bank account. And then what's the purpose of the bank account? You can pretty much just deposit and withdraw, right? So I can technically add the method for deposit and withdraw. Like set balance pretty much just like deposit. So if you want, you can just add a better name to make it easier to understand deposit. So you see that I start to create a function right in the UML diagram instead, like to list out all the characteristics and the functions of the object bank account. Right, so this is pretty much the amount in terms of another class, like the decimal number, we call big decimal. So you deposit, and void is the type of the function or the method. Well, just like we say public static void, right? So that's what it is, void. Now when I want to withdraw, so I could do withdraw with draw the amount that I want to withdraw, right? Pass in the amount, like you see the syntax is pretty much just you create the parameters with a variable name with a column separate the type. So this is the type, big decimal is a type, just like double as the primitive type, but this is just like the class type. And If I want to return the amount of the money that I withdraw, I could just, instead of void, I could just return the decimal type, which is I call big decimal, like amount of the money that I am returning back instead of void. So this is pretty much a UML diagram that you start to use to design your class. So let's say we're going to create a UML diagram. Let's say in your class exercise, you're probably going to use this to help to draw your UML diagram. Technically, you can just create a simple table, but I feel like this is even easier because when you type the UML, it's just create a list of the template for you. You just drag and drop. You don't need to draw a table. It just tell you what's the class name. In our case, what's the class name? Bottle cap, right? And we have the attributes. Attributes just those variables, right? Or the characteristic of your class. What are the attributes? Now we have plus and minus. So if you don't put anything, just like this is called default. If you put private, that's minus. If you put public, that is plus. Okay, like this is just telling you the scope of this variables. Like for example, if you look at system, they make it as public. That's why when I use hello world, I can say system.out to access to the public. If this is changed to private, I technically cannot access it anymore. Okay, from different class. Okay, so now if I decide to be private, not letting other people access it, then I do minus. Other people mean other classes. And then this is pretty much just like when we design, we said color, right? So the type of the color we separate by colon. So this is how you design a UML diagram for the class. Size, we say double as a type, and we only have 2, right? So that's how you draw a UML diagram. Like I said, we only concern the UML diagram just used for designing the software application. Now we just design at the level of one class object, bottle cap, right? Now, how about the methods? That's why we don't have to worry about how to implement it. We start to design, we said seal. So will it returns anything? That's the name of the method. So you have to put parentheses for the method. You want to put parameter in? Yes. You probably want to pass like the way you seal, right? You can loosen and tighten, right? What else? How many ways you can seal the bottle? So probably it's gonna be string type, right? Or you can say you do counterclockwise to or clockwise to, right? Seal and unseal, right? Maybe instead of seal, you see that this is a better way to design application. Instead of go and keep typing and then it's not doesn't work like before we say seal and unseal. Why don't we just say turn? Turn may be better, right? And the direction you turn, right? By pass in as right a string, left or right. Or if you want to even put in more scales like how many turns to type, then you can even change this to when.
Can you like make it like you like if you type like
one, it'll turn 45
directions. Yeah, like maybe in the degrees or whatever, right? You can even more precise in here, right? Like now I want to selection left or right, or clockwise or counterclockwise, and then I'll pass another parameters. Like if you want to do how many degrees when you start the turns, 360, that means one turn, right? Then you tight. We never really look at this, right? Go back home and look at your bottle. How many degrees when you turn is going to make it tight? It's actually about 360.
Really? Damn.
And about 360 you open it. It's just one round, right?
Yeah. That's crazy.
So degrees, right? Degree is going to be what? Int type
No, is it
or radians or
two something? I don't know, never mind. I'm thinking about something else.
yeah, if you allow to have, now we talk about degrees and radians. Degrees, is it always have this
360.
whole number? No, you can have decimal too, right? Then in is, you see, this is at the design level, so you keep changing here. It's easier to do it this at this right at this layer or level. So degree maybe it should be a double instead, right? Because we start to think about the application, right? That we try to design here. With returns, the method now at the point we pass in direction and degree. That's pretty much it, right? To turn can be open and shut. Now the result should return then, right? That is it going to be seal or unseal or open or shut, which is a string type, should return back. That's why I make it return a string to tell the status right after a turn. That makes sense? Now, how would you set the color of the cap? If these are private, there's no chance that another class like bottle class is going to use the cap. They cannot set the color of the cap. That's why we're going to have what we call setters methods. You can make it public too, but it doesn't make sense to make it's like we try to learn the concept we call encapsulation or like hiding information. We don't want to exploit too many information, otherwise confusing. Just like look at the system class, we only expose in our error, then more. If you expose everything, it's kind of confusing to use. Just like when you drive a car, you want the engine to be exposed to show you everything how it works, or you actually want to focus on the road. You don't want to really to think about whenever I accelerate the accelerator, I see the engine moving with the cylinders, pistols, and the gas and the fire sparks. You don't want that. You want that to be covered and hidden. That's called like encapsulation concept. Otherwise, too much for the user to know. Okay. So that's why always design at the private first, and then only make it public for the necessary like turn, because you still have to turn, right, to be public. So we have to set the color. User should be able to change the color of the cap. But if you don't allow to change the color of the cap, you could not create a setters. Like this is set color setter, and then you pass in the color, which is string values, and set is not going to return anything, so void as a type. And this is called setters, or sometimes we call mutator class. So you start to see this concept, mutator, setters, methods. And we have getters, like if I want to know what is the color of my bottle cap, then in this case it's private, I cannot see it again. I need to create a method called get color, and the get color pretty much just an empty parameter, no parameters, because it's just return the color of the cap, which is a string, right? So set color, get color turns. You could do the same with what set. You want to set the size of the cap, and you pass in the size that you want to set, and the size has to be double according to our design type, and it's going to be void because not return anything. But you can also get the size, which is going to be double, returns the size. Okay, so now if we walk through this a little bit, we learn UML diagram, right? We talk about Java doc, right? So you pretty much just need to put the comments for Java doc when you start to implement it, right? Like we want to implement buttercap, comment should go to the class level. Pretty much just explain again /2 asterisk that the Java doc comments, right? And closing with asterisk and slash. It should explain just like the way that system class explain. This is a Java doc. See that? This one doesn't show, but we see Java doc right here. Pretty much, you probably want to have your own. If I pretty much just use that, it's pretty much going to be the same as the scanner. No, the system Java doc, right? Like you want to have at that level, and you want to have at, like I want to start to implement now, right? So I have to follow my UML diagram, correct? Because I design it. You see, it's easier to just follow the design that you have created right here, right? So I have the color, string, size, double. And what do we need? Now when you create an object, okay, by the way, let me modify this before I forget, right?
Hey, Professor, did we ever decide on the class that we're gonna have at your restaurant?
When, you mean?
Yeah, remember you said we could go and code and eat at the same time.
And free food.
Yeah.
The bottle cap. Why don't we get a free Domino's first?
Yeah.
No, the Papa John's, right? We have someone work for a manager at Papa John's. When we never decided when we're gonna have.
Yeah, how about this? Shahir will bring the Papa John's, and then we can go to a restaurant. We can have two, like a.
That's good.
Yeah.
We should do that before Thanksgiving.
That's our Thanksgiving feast.
All right, so come back here. So the buttercap class simulates the action of the bottle cap. Okay, that's it.
So a class is an object?
Is this, what is this? Is a class an object? That's a good question. What is this? Is a class an object? This is a class button with the attributes, the method. See that? Attribute X and Y, the size, label text, position, method you draw, press, register. It's not even telling us how. A class is an extensible program code template for creating objects. Is it an object? You use the class to create objects. So just like the bottle cap again. How do you make the bottle cap? In the real world. Bottle cap object. How do you make a bottle cap? Plastic mold, right? You have to create a mold and then you have to put a plastic into that mold to make the figure to be like the size and the color that you want, right? So the class just represent that mold pretty much. Because when you create a class, you just say a bottle cap create from the class in Java, right? Simulating it. Now, it could, in this case, let's say it's just a template, right? Or, yeah, like a blueprint or a template, right? To make bottle caps objects. Like once I get that out, I can instantiate like thousands of bottle caps to use. This is object-oriented programming. You think term of I want to produce million bottle caps. I just loop through and instantiate million of them. You see the picture that way? Right, because we're going to use it to seal million of the bottles, water bottles.
And we can have several objects in class.
We can have many objects in the class to build one object depending on another object. Just like if I build a car, so many objects to build a car. Seats, steering wheels, tires, wheels, engines.
Leather, like fabric.
In one class, you can have uncountable number of objects, screws, nuts, bolts.
That's crazy.
It's depending on how complicated of that, right, class that you try to build. Like, look at the system class. So many objects, properties, map, security manager, channel. Those are objects, right? To build that, right? Yeah. If you think that way, maybe you give up on programming. So complicated. But just enjoy and look at one by one. I mean, you're not going to build this on your own, just like no one building a car with one person. So same thing. You just need to learn how to build a little bit, right? But you just need to learn a little bit on how to build. Then you can start to build a little bit and contribute to the team. So that's why now this thing made me think about how could like Bill Gates build an operating system. Of course, I don't think he's gonna build on his own, right? How could like Mark Zuckerberg has the Facebook system?
Hard work.
There's no way that one person can build that whole system. It's impossible that one person gonna build the whole house, whole car. It may be possible, hard work, and a lot of late night sleeps, and entire life.
No life.
Right? You can spend, keep building, right? Then you get it, and then you old, then you sleep in the house and die in there.
But no life.
That's what it is, right? Do you think you can build a house on your own from scratch? Everything, like the door, you cut the wood,
How long do I have, Professor?
right?
The rest of your life.
Oh.
Maybe you're gonna be that 3 pigs, right? You're gonna build a house with the stars. That's gonna be easier.
Or you could like build it out of bricks and then put straw around the bricks to trick him. So when he tries to blow it down, he'll blow the straw away, and then there'll be bricks. He'll be like, oh.
I mean,
Will come.
like building the application, you've been using it. You have to really thank you to the one who built it. They make it so seamless that easy to use. Right when you look at your smartphone, you thought that building one is going to be simple because it's so simple to use.
Yeah.
Right now, only want you to build Hello World is so complicated already. It takes you about maybe 2-3 weeks. Correct?
Yeah.
To say Hello World, even longer than that because you have to have the general studies from kindergarten up to this point
That's crazy.
to just write a Hello World program. College, first year, freshman, or maybe in high school somehow. But I'm sure the 5th grade not gonna be able to. Maybe Hello World is 5th grade, but kindergarten not gonna be able to do it yet.
Have you seen that like 13-year-old kid who got a job with Google, who like is like really good at like? Do you know who I'm talking about?
All right, I think let's come back. Okay. Now, so we answer that class can have many other objects. So let's look at this class again. The one that we still need is whenever I want to create an object of this class, how do I do it? Let's review the code again. When you create the object of scanner class, how do you do it? This is how you create object named keyboard, right? Pretty much object that created from a scanner class, and you call a method, right, with the parentheses, a method named scanner, a method that has the same name as a class name. We call constructor. So we're missing that here. So just like bank account, see that? You could have many constructors, like constructor with no parameters, constructor with the account number. Why we want to have many? Because sometimes you can create account and you don't have to, like, you could have number, account number, and account name and the balance, right? But sometimes you don't have any balance. You just want to have account number and account name. There are many ways to create the object and giving the initial value to it. That's the point of the constructor, giving the initial values to the object. Like in this case, we could create what? A bottle cap. How do we do that? It has to be public. Bottle cap with no parameters, meaning it's going to give you maybe the white bottle cap. We can put initial value to white when you don't have any parameters, and the size could be standard size, right? Now if I want to customize a little bit, I could just pass in parameters like color, string, right, comma, size. I could make the size that I want, right? Or I could just say, hey, just actually have the constructor that taking just the color, and then the size always going to be one size standard, right? So this is called overloaded constructors. Like overloaded is the concept that the method has the same name. Like these are the method that has the same name with different parameters, values. So these are constructors. And lastly, we need one more is the description of the bottle. Like we're going to return this bottle cap is white with 5mm size, something like that. So that's why we should have two string, like return the description of this bottle when I call the bottle cap. So that's pretty much when you design a class, they should have those constructors, the fields, right? Setters and getters, two string. So those are the common thing that you should have. Okay. Now we use UML diagram. We create Java doc, and we learn how to create an object, right? Create object of a class, instantiation and instantiating, right? Define Java class and its methods. In the UML diagram I show you, right? What are the methods? Describe how parameter works in the method definition. So let's say we have getter and setters and we have constructor, right? Let's say I'm going to create, I'm ready to pretty much just according to our design, we're going to write the code for the bottle cap, right? So this is pretty much the code where we're going to have the attributes. What else do we need? Constructor, right? So constructor plus mean public. And constructor pretty much just the method that has the same name as your class name. Default constructor. You could just set the initial values like color equals to what? White cap, right? Size equals to, you know what's the size of your bottle caps?
Probably like half an inch.
No,
No, it's
more
not.
than
It's not more than an inch. At the most.
1.25, then we are happy. 1.25 inches. Alright, so
The diameter?
yeah, diameter size, maybe there's a better name, right? You see that? That's maybe a bit better name, right? Please be more specific. You don't need to actually, but you should put in Java doc. That's why when we do Java doc, you should, like now, if you have another constructor that dealing with what? Passing in the name. So we have to say string color, right? What else? Double size, right? Then that's the point of Java doc. That's why this point I said describe how parameter works in the method definition, right? So parameters, the diameters. If you don't name diameters to make it simple, right? Then you have to explain, right? The diameters of what the bottle cap, right? color of the bottle cap. So that's why Javadoc is important here. When you pretty much when you use scanner, you start to read Javadoc. When you use string class, math class, you read Javadoc. So create object of bottle cap, right? So that's pretty much just what you need to define in your constructor, right? At each level, this is we try to create Javadoc, right? Comments. And now, when you have the parameter name as same as the fields of your class, you want to say this refers to this class name bottle cap. Just like when you do like scanner dot or system dot, right? This just like that, and then you do dot access to the attributes, which is the color, right? Equals to the color right here. Then that's how you refer, because there's the same name. Now you know you refer to the color attributes of the bottle cap and passing the color to set the color. Just like the size also. That makes sense? So I have constructors according to our design, UML diagram design here, right? And I should have another constructor that take only string, right? So let's create another constructor that take only string. Apparently I can just copy this part and delete the size one. Now I have to set up the initial size in this case. Okay, so we start to create what the methods, right? Any questions? What time is supposed to be done?
5:40.
Okay, now we're gonna finish this method then. So we're going to create turn, right? That's the next one. So turn return string. So string as a type now because returns, right? Turn has two parameters: string direction and another parameter degree, right? You see the UML diagram just has the opposite, right? Now you're gonna have an error if you not return, right? So now we have to implement turns, right? So if direction, now this is string, we use the method equals to help, like clockwise. You see, this is also a good thing about, if you look at this in details, you start to see you should define this more into, because people can talk about turn left, turn right, turn clockwise, turn counterclockwise, right? So that's why enum come into place. Remember we talked about enum, right? So enum, remember, just give the type. You can create your own type like direction, right? As a type. Okay. Like for example, No, I'm gonna make it simple first. Otherwise, we just I'm gonna use direction for now. We don't want to get distracted. So now let me just use clockwise, right? So if direction equals to clockwise, what do we do? Degree we also depending on the degree too, right? Like 360 is going to be opened, right? So if we do nested if, degree greater than equals to 360. Now we're going to set the status. We declare status. By default, we're going to make it crossed. So when it's clockwise, actually it had to be counterclockwise to open. Counterclockwise. Degree greater than or equal to 360. Then we change the status to be open. That makes sense. Now we return just the status. The rest pretty much just what? Close. Right? Degree if it's not greater than 360, the status still close. If it's not counterclockwise, that means you close, right? So that's pretty much just logic, which this could be more complicated depending on the application or class that you created for, right? Or the object. Now we're gonna have to do the other methods, right? Set color, get color, and to set size, get size, and to string. All right. So those methods are very common. You can actually generate them using set and getters. Right, let me show you again. Right click, generate, get and setters. And these are two attributes that you want. So it's going to write a code for you. It's pretty much the same concept like get color, return string, set color, pass in and set. So same toString is a standard one. You technically can generate them, as well as the constructor. I didn't show you because I want you to actually learn how to do it first. So we're pretty much done with the BottleCap class according to the UML diagram here, right? Now first time I would recommend you to type them all out first before you use the generating. Then you learn first. So we're done. How do we use BottleCap? We create our own class. This is the same way that we use what? Scanner. I can technically say BottleCap, right? And the name of the object. Okay. New BottleCap. I just create one BottleCap here. So this application just to test. So I just create a BottleCap. And what is the constructor that I use? The default. Which the BottleCap is gonna be what? White at 1.25, right? Okay. You have been given a BottleCap. A. Maybe. Hey. With the username. Okay. So let's run the application and see. I just create it and I call body cap. Now when I call body cap, normally I have to do .toString to get the method, to get the description of it. But the special thing about toString is you don't need to do .toString. It's gonna call toString for you. Hey tennis, you have been given a body cap, color white, size 1.25. Like, because I call the default, right? Now if I actually call black and keep my own size, which is 1.0, okay. So it's going to pretty much just, yeah. Okay. Hey Andrew, you have been given a body cap color black, size 1.
Last letter should be an S.
Address, right? Okay, so that's how you use it. Now let's look at your assignment. So your class exercise. Now this is just simulating just how bottle cap work, but in reality you have to create a bottle class. You're gonna use bottle cap in bottle class, and this guy Andre has actually have to purchase a bottle cap, bottle, water, and then do the turns, simulating the whole thing. Makes sense to do each action. Right, this one we just didn't do much. Like you could just simulating an action. Like you have just, and when I say water cap dot what turn, and I put a direction counter clockwise, right? And the degrees 368. Okay, so it's gonna give you a status, right? Hello Che, you have just opened like the bottle cap, right? The bottle, you see that because of that action. Make sense? Alright, your class exercise. Now you're thinking in terms of object. You see that? That's how you develop the application now to simulate the real world situation. You're gonna have to create a person class, constructors for that, with 2 constructors, one with the default and one without parameters and one with the parameters, right? Name and age. Set a name, set an age, get a name, get an age. And you have to do toString, information about person. You're going to create another class just like with the main method now, person driver, right? You're going to create 2 persons. Now I just create 1 bottle cap, right? Oh, 2 actually, right? Or 1 actually, I don't remember. 2, right? Or 1. I could do another one, right? 2. And then you start to compare, right? 2 objects. Now give them the same name, right? 2 person objects have the same name and the same age, and start to compare them, and start do the same thing with different name, different age, and see if 2 objects are equals, if one are younger or older. Make sense? Use Java doc, create Java doc, UML diagram, and submit on github.com. That's pretty much it. Alright, thank you for watching.